Hello everyone, welcome to Tutti Toot. In this session, we will see previous year questions from the Genco Transco and SSC Junior Engineer and some of the other PSU exams also. Okay, let's see the first question. So in a PMMC instrument, the damping provided is, okay, so they are asking in PMMC type of instrument, what is the damping mechanism provided? Okay, so which kind of damping mechanism is used in PMMC type of instrument? Okay, so this is one of the previous year question in the Distribution Company Limited. So, and this is okay, so many exams, so they have asked this one. Okay, so in PMMC, what is the damping mechanism? Okay, so remember one thing, so the damping mechanisms whatever we have, so those are eddy current damping mechanism. Okay, so next one is air friction damping mechanism, and third one is fluid friction damping mechanism. Okay, so fluid friction damping mechanism, these are the major damping mechanisms. And another one is so electrostatic damping mechanism. Okay, so electrostatic damping mechanism, so but this electrostatic damping mechanism is very costly. That's why in this moving instruments, otherwise indicating type of instruments, we are not preferring this electrostatic damping mechanism. Okay, so because it is more costly. Okay, so economic wise we are not preferring this one. Okay, so but you see in all these things, which is the good one means eddy current damping system, damping mechanism is greater than air friction damping mechanism is greater than no, actually, so fluid friction and air friction same operation only. So generally these two are same, but when it comes to superiority, okay, so which is more superior means, so this is, okay, so fluid friction is more superior when compared to air friction. Okay, so let's see the order. Okay, so eddy current damping mechanism is greater, after that fluid friction damping mechanism, after that air friction damping mechanism. That means any instrument, first we will check with eddy current damping mechanism, it is possible or not possible. Next fluid friction damping mechanism, next air friction damping mechanism. Any instrument first we have to see like this only. Okay, now we will see the PMMC. Okay, so in PMMC, okay, so which kind of damping mechanism we are using. Okay, so for understanding, if you know these concepts and all within second, okay, so it is like only 1 second you can answer this question. Okay, so see one thing, when we can use this eddy current damping mechanism means wherever permanent magnet is there, wherever strong magnetic field is there. Okay, strong magnetic field is there, so there, otherwise wherever continuous magnetic field is there, there we can use this eddy current damping mechanism. Okay, you see PMMC means permanent magnet we are using, so we can use eddy current damping mechanism. Okay, so in PMMC eddy current damping mechanism is used. Okay, so fluid friction and air friction also we can use, but this is the superior one, so this only we will use in this PMMC type of instrument. Okay, similarly all other instruments also. Okay, so basic questions they used to ask. Okay, so PMMC, what is the damping mechanism we are using? So eddy current damping mechanism. Okay, so eddy current damping mechanism we are using. And next one is moving iron type of instrument, which kind of damping we are using means we are using air friction damping mechanism. You may get doubt, in fluid friction mechanism we can use here, right, but we cannot use in this moving iron type of instruments, because whenever you use the fluid inside, okay, that fluid may damage, if it comes out of that vessel, it may damage the instrument parts inside. Okay, that's why we don't prefer it. Fluid friction damping mechanism and air friction damping mechanism is preferred for in this moving iron type of instruments. Okay, next one is dynamometer type of instrument. Okay, so dynamometer type of instruments, so we will be using, okay, so dynamometer type instruments we will be using air friction damping mechanism only. Okay, so air friction damping mechanism. Okay, so these three we have to remember. Okay, so very important, these three, so they have asked so many times these questions. Okay, that's why I have given. Okay, so anyway directly for this question answer is eddy current damping mechanism. Okay, next question, identify the instrument which has no controlling torque. Okay, so some instrument is not having any controlling torque, they are asking what is that instrument. Okay, let's see, electrostatic voltmeter, power factor meter, watt meter, dynamometer type ammeter. Okay, so any instrument definitely controlling torque is required, right? Okay, so controlling torque is required. Okay, so in some instruments, okay, so controlling torque is not present. So I will tell you how it is. Okay, so controlling torque is absent. Okay, so in which type of instruments means there are two instruments we are not having any controlling mechanism. Okay, so that means we are not providing controlling mechanism, automatically inside controlling mechanism is there. Okay, so in one of the instrument is Megger. Okay, so one of the instrument is Megger, another one is power factor meter. Okay, in these two instruments, okay, so no controlling torque. Okay, so in these two instruments, no controlling torque. Okay, remember this bit. Okay, I will tell you why no controlling torque means. In these two instruments, okay, there are cross coupled coils. Okay, cross coupled coils means so one coil will provide against the another coil the force. Okay, whatever force or torque it is producing, one coil torque it will oppose another coil torque. So it is just like, okay, so these two are the coils, this is the indicating one. Okay, so whenever, otherwise moving system, we will consider this as the spindle. Okay, so whenever these two coils are like moving in against to each other, okay, so then whatever equivalent, because of this or because of that equivalent only, this moving system will be rotating. That means no need of any controlling torque in the Megger and power factor meters. Okay, let's see the options. Electrostatic voltmeter, power factor meter, wattmeter, dynamometer type ammeter. Okay, so dynamometer type ammeter, wattmeter is also dynamometer type only. Okay, so wattmeter is also dynamometer type. Okay, some induction type of wattmeters also there. Okay, but generally dynamometer type of wattmeters only we have. Okay, so in dynamometer type, which type of controlling torque we are using? Spring control. Okay, so spring control we are using. Okay, so these are some of the other bits. Okay, so let's see the another question. So a meter has a full scale angle of 90 degree at a current of 1 amperes. This meter has a perfect square law response. Assuming spring control, the current for a deflection angle 45 degree will be. Okay, so they have just given, so complete. Okay, so complete this scale is about 90 degree. Okay, so at 90 degree, for example, from here to here we will consider this as a 90 degree. Okay, so this is complete 90 degree. They told for 90 degree the current is nothing but 1 amperes they told. Okay, so this is 1 ampere, and for 45 degree, what is 45? Exactly at the half. For this 45, they are asking what is the current. That's it. Okay, so for 45 degree, what is the current? And it is following the square law, perfect square law. So that means theta is proportional to I square it is. Okay, so theta is proportional to I square. Now simple. Okay, so they have only told it is following the perfect square law. That means theta is proportional to I square. So theta 1 divided by theta 2 is equals to I1 square divided by I2 square. Okay, so that means theta 1 is 90 divided by, so this is 45 degree is equals to I1. What is I1? 1. Okay, 1 square divided by I2 square. Okay, you can just do this one. I2 square is equals to you will get 1 by 2. Okay, so 1 by 2, because this side it is 2, so if it go to other side it will be 1 by 2. So I2 what you will get? So that will be 1 by root 2. Okay, so what is 1 by root 2 value? So 0.707. Okay, so that is the 1 by root 2 value. Okay, so 1 by root 2 is 0.707. Okay, so directly if they won't see, if any of the student don't see this perfect square law, then what he will do? For 90 degree 1 ampere, for 45 degree it is 0.5. Okay, so when it is possible, if theta is proportional to I, if it is following the perfect linear scale, otherwise uniform scale it is following, then for 45 degree what you will get? So 0.5 amperes you will get. Okay, for the perfect square law what you will get? 0.707 amperes you will get. Okay, so for which type of instrument it is possible like this means generally for the true RMS meter. Okay, which instrument is following perfect square law means true RMS meter. Okay, so true RMS meter is following perfect square law. So generally we might have considered, okay, for the moving iron type of instrument, while we studying for the moving iron type of instrument, theta is proportional to IRMS square. This is what we have understood. Okay, so that means here something we have just assumed, dl by d theta we have assumed there. Okay, so that's why we got more errors in the moving iron type of instrument. Okay, so anyway, answer for this question is 0.707. Okay, Next question, pick the odd one out. Okay, so the instruments they have given 4 options. They are asking pick the odd instruments. Okay, that means moving iron meter. Okay, so moving iron meter, moving coil meter, dynamometer, watt meter, whatever meter. Okay, so generally we will see what are these instruments. Moving iron meter, how it will work? We can use as ammeter, we can use as voltmeter, but only for DC. Okay, moving iron, right, we can use for AC or DC. Okay, so moving iron means we can use for both AC and DC. Okay, so this is moving coil instrument. Okay, so moving coil instrument we can use as a ammeter, voltmeter, and we can use only for DC. Okay, and dynamometer type we can use for both AC and DC. Okay, so both AC and DC. Wattmeter they are using, we can use for both AC and DC. Okay, so they have only mentioned it is wattmeter. Okay, here they told only meter, so how we can just modify that meter? I have just given ammeter and voltmeter. Okay, so and whatever meter means energy meter. Okay, so energy meter, this generally we will be using induction type. Okay, so these are all induction type only. So but anyway, with small modifications we can use for even DC also. We can use for both AC and DC energy measurement. Okay, these are energy measurement, this one. Okay, and these are 2 types of analysis for this question. Okay, let's see. If you consider based on the DC and AC means this is moving coil meter will be using only for DC. That is the answer generally. Okay, so that is the answer. Option B is correct. There is no problem for this. Okay, so this question ends. Similar question. Okay, so same question only we can think in a different way. Okay, we can think in a different way. How it is possible means, so any of these things. Okay, so this dynamometer type of wattmeter, basically it is the instrument which is working based on currents. It is working based on current. Moving coil instrument is also working based on current. Moving iron instrument is also working on current. But whatever meter, okay, so inside there are currents only, but energy, it is representing the energy directly. Okay, so that means this is the energy. These are all power, whatever voltmeter, that means voltage and current we can consider. Okay, so we can, there are certain examples like this. This is measuring energy and remaining all are directly current measuring instruments. Okay, so like that we have to understand. Okay, so whatever output we are getting, so whatever these are indicating type. Okay, you can understand this is indicating type, this is indicating type, this is indicating type, but this is nothing but integrating type. Okay, so that is also one of the understanding. Okay, so this is integrating type. Okay, so what is indicating type? Wherever pointer and scale is there, that is nothing but indicating type. Okay, so wherever, so this integrating means wherever registering mechanism is there, just like our energy meter. Whatever meter is nothing but watts into hour. Okay, power into time is nothing but energy. Okay, so this is nothing but energy meter only. Okay, so whatever meters we are using outside our home, okay, so that is nothing but whatever meter only. Just go and check once. Okay, so energy meters are some whatever meters we will be using. Okay, so this is integrating type of instrument. That means if now this month reading is 165 units, that means 165 revolutions here, that means next month it will be adding. Okay, next month for example 20 revolutions means it will be added to the previous value. That is nothing but integrating type. Okay, so anyway, generally they used to ask based on a type of instrument only. Okay, so this is indicating type, this is indicating type, this is indicating type, and this is nothing but integrating type. Okay, so integrating type. So option D. In that case, option D it is. Generally question will be so little bit more clear, but at that time, okay, they used to give like this. Okay, so anyway answer is D for this one now. Okay, so but there is chances for this B also. If they mention, okay, based on the supply, okay, so based on the supply to the instrument, pick the odd one out, then we can choose this one. Okay, so based on the type of instrument, then we have to choose this one. Okay. Next question. In current transformers, turns compensation is provided mainly to reduce the turns compensation. Okay, so what is this turns compensation means? To avoid the error or to compensate the error in the transformers, current transformer or voltage transformers. Okay, so voltage transformer means potential transformer. Okay, so generally in instrument transformers, okay, in instrument transformers there will be two types of errors. First type of error is nothing but, so if you take the errors, two types of errors. First type of error is nothing but a ratio error. Okay, so ratio error, and second type of error is nothing but a phase angle error, otherwise phase error. Okay, so phase angle error. Okay, so these are the two types of errors. So what is this ratio error means? So the turns ratio error it is. Okay, so generally this current transformer at the primary is having only 2 turns or 1 turn only, or very less number of turns, and secondary is having more number of turns. That's why CT is step up transformer. Okay, CT is current transformer is step up transformer, because primary has only 1 or 2 turns, secondary has many number of turns. Okay, so whenever you have many number of turns, thickness of the turn will be less, then sometimes some of the turns they will disappear and they will make, okay, just like smaller turns will be there. Okay, so these are all very small thickness. So what happens means, whenever 2 turns will touches, automatically they will become as single turn only. So there will be number of turns, some changes will be there. So automatically primary to secondary, so there will be turns ratio problem. Okay, so in the current transformers this problem is there. Okay, so now what they are asking, in current transformers turns compensation is provided mainly to reduce which error? Ratio error. Okay, so what compensation we will do means, we will do the turns compensation. Okay, so we have to just balance the whatever ratio is there while designing, same ratio we have to maintain even after also. Okay, that's what compensation we have to do. Okay, so anyway, ratio error it is. Okay, so next one, the resistance of the circuit is found by measuring current flowing and the power fed into the circuit. If the limiting errors in the measurement in power and current are plus or minus 1.5% and plus or minus 1% respectively, the limiting error in the measurement of resistance will be. Okay, so just whenever this model of questions are coming, percentage limiting errors. Okay, so just consider one thing. So whatever power formula, what is the power formula? I square into R. What they told, resistance they have calculated based on power divided by current square. Power divided by current square. Okay, so this is the formula what they have given. In power, what is the percentage error? Plus or minus 1.5. Okay, in power and current R, 1 plus or minus 1.5 plus or minus 1 respectively. So in this error is nothing but plus or minus 1.5%. In this, what is the error? Plus or minus 1%. Okay, so whenever you are calculating a percentage error, whatever numerator and denominator, in percentage we have to add directly. Okay, so in percentage, whether you are multiplying, okay, so whether you are multiplying or dividing, so what you have to do? Percentage errors we have to add. 1.5% and 1%, total it is plus or minus 2.5%. That is the answer for this. Okay, plus or minus will be 2.5% it is. Okay.